Peach's perfect pen. Tiffany has a strip of sheet metal that is 200 centimeters long. She wants to bend to make a rectangular pen for her hamster Peaches, right? That's why it's Peach's perfect pen. The pen is to have a perimeter of exactly 200 centimeters, right? It's a 2-meter strip of whatever. And being a humane pet owner, Tiffany wishes to make the largest pen possible so Peaches has plenty of room in which to scamper about. Not knowing which dimensions would give the pen the maximum area, Tiffany decides to test several scenarios by varying the width of the pen. She uses the perimeter formula, P equals 2L plus 2W, and begins with a width of 10 centimeters. Okay, so we make this pretty narrow pen. Maybe Peaches is training for sprints or something. If the width is 10 centimeters, then what's the length going to be? 90. Okay. And the area of the pen is? 900. 900 what? Centimeters squared, right? Yeah, that's good. Got the units and measurement stuff down. Since Tiffany is going to test several values, she sets up a table of values as shown below. Choose a reasonable set of values for the width and complete the table below. Okay, so we're going to go by what? Tens, right? That's likely what's going to fit in there, so 20. $100. Okay. So if the width is 0, what's the length? 100. And 10, we decided it was 90. I don't know, how did we get 90 anyway? 100 minus 10, right? Because it's 2L plus 2W's got to add up to 200. So L plus W has to add up to 100. So all we got to do is go backwards, right? We're just going down from 100. And, so we have the measurements in here, right? So we don't have to write centimeters next to each one. We've said this column is in centimeters. And so now we just calculate the areas, right? Okay, so go ahead, you do that. You can actually use a calculator if you need to, or, just... And okay, so number 2, it's that part of number 2, right? Done. Chosen a reasonable set of values for the width and completed the table. So now, how's that there? So this isn't exactly like yours, is it? So the independent variable is the variable for which you choose the values. The dependent variables are the values that depend on what you have chosen for the independent variables. Okay, so that means that we must be asking, what is the independent variable? Which one did we choose values for? The width. Right? We chose values for the width. So when we did that, what were the dependent variables? Length and area, right? Okay, so the length depends on the width by that relationship of perimeter, and the area depends on width. On the grid above, use the values for the width and area to draw the graph that describes the relationship between the area of the pen and the width of the pen. Label the axes. Okay, so this will be width in centimeters, and this will be area in centimeters squared. Right, and then we are going to plot the set of ordered pairs that are in the table here. I think that's why this one is arranged a little differently than yours. Okay, so at a width of 0, we have 100. What's the scale on this? What's it going by? Okay, what is each minor tick? 200, right? Okay, so we got to figure that out. You should always very carefully look at the scale of your graph, right? I mean, because too much, especially when we're just doing normal ones where it's like, 1 to 10 and 1, 10, negative 10 to 10 and stuff. Because we get in the habit of assuming it's always going to be that way, and all of a sudden it goes like 2, 4, 6, 8, and, answers get wrong. So you just figure, okay, so there's 1, 2, 3, 4, 5 and 1,000. 1,000 divided by 5 is 200. Okay. So we've got width 0, 0. The width is 0, there's no area. 10, width gives us 900. 20 gives us 1,600. 12, 14, 16. 30 gives us 2,100. 40 gives us 2,400. 50 gives us 2,500. 24. It's kind of symmetrical here, right? Okay. Now, is this graph a discrete graph or a continuous graph? Continuous, right? Because we can vary the width. It doesn't have to be 10, 20, 30. It could be 15. It could be 25. It could be 21.7. Or we could choose any value we want. Given that we can choose any value we want, then we join the points. What shape is this graph? Parabola, yeah, parabola.
Oh, sorry.
It's okay. I'm blind here. I'm drawing what I can't see. It's kind of ugly, but we'll leave it. Okay. So there we go. I suppose there's questions further down, right? The grid above describe the relationship, label the axes. Yes. What is the name of this curve? Parabola. Okay. This is a quadratic function, right? This unit's called quadratic function. Yeah, and inequalities, right? Then we do quadratic equations, a lot of quadratics. The domain of relation is the set of all possible values of the independent variable, which was what? The width, right? Width is independent. And what possible values can we give for the independent variable, this width? So what's the lowest width we can have? 0. And what's the highest width? Okay, and here's how we write it. 0 is less than or equal to W is less than or equal to 100. Okay, so it's always, when you're writing domains or ranges, right? So low value is less than or equal to the variable is less than or equal to the high value. Okay, so the width is between, and then just a fancy way of saying it's between 0 and 100, right? Or more accurately, between 0. You're going to come in this time?
Sorry, I didn't know.
Yes. He's actually fairly smart, so it's hard to believe. Oh, somebody get a package. Oh, awesome. Yeah. That was nice. All right. So, width. The range of relation is a set of all possible values of the dependent variable. Okay. What is the range of this relation? Damn it. Grab the... Okay, so what's the range of the relation? 0 to 2,500, right? So it would be the area, right? Area is the dependent variable, at least the one we're graphing, right? We have length is dependent, and so is area. We're interested in it, right? We're trying to make the largest pen we can for peaches, so it's area. Okay, and what do we say? 0 to 2,500. Right? We could label this, we call that the W axis and the A axis, right? I if we used X and Y, it's legit. I mean, it's more, it's clearer if we use W and A. But if you labeled that X and that Y, then you would have an X instead of a W for the domain and a Y instead of an A for the range. Okay, good. Okay, back to my guideline. Please. Forward. What is the maximum area of the pen? Is that a nice question? No. So what's maximum area of the pen? 2,500, right? Where did we find that? Hop back for a second. So that's here, right? There's the maximum point, right? Maximum area, right? It's a graph of area. This is the maximum. Maximum. Okay, so we have a maximum value there. What width and length give this maximum area? 50-50. So 2,500. And width and length give this width 50 centimeters, length. The vertex of a parabolic curve is the exact point where the curve changes direction. So as it was climbing, right? We're getting larger and larger and larger areas until we maxed out, and then they become smaller. So we're changing direction. What are the coordinates for the vertex of the curve?
50 and 2,500.
Yeah, 50 and 2,500. Okay, so anytime you're doing coordinates of a point, it must be enclosed in parentheses with a comma in between the numbers, right? And that tells everybody in the world looking at it, that's the coordinate of an ordered pair, right? That's a point on a graph. If you just write 50, 2,500 without that, then it's just two numbers, right? You get a list of two numbers. How does the vertex relate to the maximum area and the width of that maximum area? So what's this 50?
The width.
And what's this?
Maximum area.
Max the area, right? Okay, so how does the vertex relate to the maximum area? So the x coordinate, well, let's say the first coordinate, because we called it W. And the second coordinate so the first coordinate is the width, and the second coordinate is the area. Actually, well, the maximum area, right? So the area is maximum. And this is the width that gives us excuse me, the maximum area. So the first coordinate is the width, but it's the width that gives us the maximum area, and the second coordinate of the vertex is the area, but it is the maximum area. What's the minimum area of the pen, and what are the width and length that give this? So the minimum area is 0. Minimum. And this is given by what? A width of 0 and a length of 0 centimeters and a length of 100 centimeters. Is there another way to get it?
Yep.
Or a width of 100 centimeters and a length of 0 centimeters. So unless Peaches is a two-dimensional hamster, she's not going to fit in that pen that has an area of 0, right? Note that the curve is symmetrical with respect to a vertical line called the axis of symmetry. What is the equation of the axis of symmetry for this curve? Okay, let's go back to the so this is the axis of symmetry. It's not symmetry. Symmetry, 2 M's. I think I know that by now. This is the maximum. I'll just put the coordinates on the maximum. Oh my god. Okay, so there's the maximum, there's the coordinates of the maximum, there's the axis of symmetry, right? So the axis of symmetry is a vertical line. We have drawn it, and what is the equation of this vertical line? W equals 50, right? The equation of the vertical line, right? So I'm labeling it on here, but we're also going to write the answer down in the answer section. So W equals 50. Okay, so we've drawn it on the graph and we've got the equation. Use the graph in question 3 to estimate the area when the width is 25 centimeters. Okay, so how do we do that? Got the width, we come across to 25, and then what? Go up to the graph, and what is our estimate? 1800? Okay, remember, it's an estimate. We want exact, we could calculate that. So 1800 square centimeters. Use the graph in question 3 to estimate the width when the area is 2200. Okay, so in this case, we kind of do reverse process. We now come across from 2200, 35. Well, actually, there's 2 of them, right? 35 or 65. Okay, because there are 2 width values that give us an area of 2500. So 35 or 65 centimeters. Okay, technology. You can use technology to help you graph relations. However, for the calculator to be able to graph relations, it needs to see an equation that uses x and y as the variables, and the equation must be written in the form y equals. If the perimeter of the pen is 200 centimeters, and x represents the width, and L represents the length, write an equation for length in terms of x. Okay, so let's go back to the original formula for perimeter. Let's put in, so x represents the width, y represents the length, and we know the perimeter is 200, right? So we're going to get 200 equals. And
Sorry, I thought L represented length.
x represents the width. Oh, right. No, and L, what? Oh, okay. Yeah. You're right. Sorry. My bad. 2L. It's good. Keep me honest. We want a good video coming out of this, right? For whoever might not be here. Actually, I think everybody might be here. All right, so what do we want to do? Write an equation, solve. So solve that for x. We want to get an equation that says x equals. X equals. I'm going to pause this. You're going to work out. All right. Well, let's divide everything by 2, right? So 100 is equal to x plus L. So what's x equal to? 100 minus L. Recall that the area of a rectangle is area equals length times width. Use this formula for length to, yeah. Oh, solve for length. Got it backwards. Go solve for L. So just interchange them, right? Read the question. Okay, very important thing. Read the question. Okay, solve for the length in terms of x. I want L in terms of x. Okay. Recall the area of a rectangle is A equals L times W. Use this formula in your equation for length to write an equation for the area in terms of x. Okay, so we have A is equal to L times x, right? Because we said the width is going to be x. And now instead of L, we can write 100 minus x times x. That kind of matches up with the table, right? Because we said 10 and 90, right? 20 and 80. What is about these two numbers? You have to add to 100. Okay, right. Use your graphing calculator to graph the area function. You will likely have to adjust the window settings in the calculator to be able to see an accurate graph. Refer to your table of values for appropriate values for width and area. When changing the window parameters, remember that x represents width and y represents area. Sketch a picture of your graph below, labeling the axes, and write your window settings in the appropriate spaces. Cool. That's got to be easy. Okay, so let me haul up a calculator. Okay, so we bring up our calculator. We want to enter the equation, right, which was 100 minus x times x. So that's y1, right? So we're going to go bracket 100 minus x bracket. You can put it times or not, or if you write an x there, I mean, if it makes you feel better, put it times, and then x. Okay, so 100 minus x times x, right? Now, we already know the window we should be using, so let's go to window, right? We're just going to match the window that's in question 3, right? You gave us a nice, right? So what are we going to say? It was like, it was actually minus 10, wasn't it? Let's do that so we can see the axis, right? I mean, although 0 would be fine. And what do we want to go to? Let's go to 110 just so we go past, right? So we've got a little, buffer on either side. And the scale will be by tens. Y min, okay, 0 is good, right? Because we know that's 0. And Y max is 2,500. Let's go a little above that, right? It's always good to, have some headroom. So let's go to 2,600. And let's scale that by hundreds. 100. So there'll be 26 of them, right? The scale, in essence, doesn't matter much, but what it means is if you put too low a scale, you just get a fuzzy axis, right? Because it's putting a tick. If I left that at 1, it would be putting 2,600 ticks, which it can't do. There's not enough resolution to do that. But by setting it to 100, we'll see 26 ticks running this way. Okay, and then just say graph. Right, yeah, there you go. Right, so graph, yours is probably gray. And have you got one of the color ones? Yeah. Cool. Yeah, I like the color. They're rechargeable. Just don't leave it on the recharger on the day of the test. Hey, bro, calculator it up, turn on the charger. Okay. Also, but when you do different graphs too, they show up in different colors, right? That's what's really. I'm not saying run out. You do not need one of these, but it is nice for here. Okay, so here's how we list windows, right? We say x goes from 0, what do we use? Actually, negative 10 to 110 by tens, and y went from 0 to 2,600 by hundreds. Okay, now you list that, or I list that, right? Because it gives you a perspective. If all you're seeing is the grid, but you don't see the 10, 20, 30, 40 on there, you can look at it and say, oh, okay, that's by tens, right? And that's by hundreds. So if I have to count. This is, again, area in centimeters squared. This is width, right? Because now our x is width in centimeters. And sketch a picture. So it says sketch a picture, right? This does not need to be trivial. You know, you can't just draw a straight line or some V shape or something, but it's like sketch a picture. Okay, so it goes like that. There's a sketch of the picture, right? And if you want, you know, you can label this. They're on 100. You don't have to go out of your way to, you know, put a tick every 10 or anything like that. You know, putting 0, 50, 100, 0, 2500. You could do a 1250 in there or something. Okay, so there's a sketch of the graph. Now, why do we use a calculator? Because on the calculator, you've got the calc function to determine the maximum area and the corresponding width. Okay, write down the steps you use to determine the maximum area. Here we go. You guys use max on this at all? Probably not yet. Maybe a little. Okay, here's what you do. Second, nice thing about the video is you'll actually see the key presses, right? So if you get lost in class, if you get lost in class, you just go back and just say, it was like 26 minutes in, right? And you just drag it to 26 minutes. Or if you just drag, you see the little thumbnails at the bottom, all of a sudden you see calculator pop up, and you say, that's what I need to see, right? Anyways, second, trace, which is calc, right? So I'll just say second calc. Maximum, what else, right? Number 4, hit a 4. Now, what it asks you is, what's the left boundary? Okay, so it's kind of at the max right now, but we don't know that necessarily. So we just say, I'm just going somewhere to the left of where the maximum is, and then you hit enter. Now, your calculator probably won't draw that. And then, and we don't support Casios, you gotta figure this out, right? And then you move somewhere to the right, and you hit enter. So what you're telling the calculator is, right, it says look between here and here, right? You're narrowing it down. And then it says give me a guess. Like I would like you to approximate where it is. Yeah, that happens all the time in this thing. Okay, good enough. And then it tells you the max was at 50, 0.0000. We kind of ignore that 0.000. Remember, this is calculated through, you know, calculator type methods, so they aren't always exact, but 50 is exact. So it's 50, 2500, right? So remember, x is width. We have a width of 50 and a maximum area, or an area of 2500. Turn that. So y and the corresponding width. Goes in that first blank. I don't even know what goes in those blanks. Yeah, wow. I got something different. Do you have something different on here?
We don't have that.
You don't have that. Yeah, it's good because. All right, so it just says maximum. So just in your maximum area, you're going to write 2500, and then corresponding width is 50. Okay. Write down the steps you used. So 10 the corresponding. Oh, that shouldn't be up here. Okay, so 2500. And the corresponding width. Somebody cleaned them up, right? So, you know, it may not always be a one-to-one agreement between, you know, just let me know, right? Say, we've got something different. Okay, so with the graph on the screen. Number 1, you go second. Calc. Maximum. So you can either arrow down to the 4 and hit enter, or you could just hit a 4. I'd like to just hit a 4, right? Because you hit 4, that also includes the enter, and it's, you know, boom, you're just in there. Number 2, move cursor to the left. A vertex. And then enter. Number 3, move cursor to the right. And lastly, it wants a guess, so move cursor close to. they're not always going to be nice, right? I mean, sometimes it'll be like, what's the, to the nearest tenth or something. Okay, and then like in this one, as we were kind of moving along, or just started out right at the maximum, okay, that's not always going to happen, so you do have to move around. You can also use second calc function on your calculator to determine the areas for various widths and the widths for various areas. Use the second calc to determine the area when the width. So in this case, it's when we know x. And here's how you work that. You go second calc value, right? You say, I'm going to give you a value. Okay, I'm going to give you an x value of 28. And then it will give you the corresponding y value, or the area in this case, which is 2016. Okay, so that leads to 2016 square centimeters. 41 point, and notice it shows you the point too, it's kind of nice. So second calc value, since it's on number 1, I can either press a 1 or just hit enter, right? Enter and put in 41.4. And we get 2426.04. Okay, questions?
Straightforward.
Use the calc function on your calculator and 2 graphs to determine the width when the area is. Okay, when we know y. So we know the y value, which for us is the maximum area. Okay, I know y. Right. I know that y is 1900, so I go to y2 and I put in 1900. And I said, what I want to find is, what's the width when the area is 1900? So when I graph this, it's going to draw a nice line across, right? And what I'm interested in is, what's the x-coordinate here? Or here? Okay, so we do that by going second calc intersect, which is number 5. Now, intersect works like this. It asks you, what is the first curve? You notice it's sitting on the blue curve, and it's got the blue equation, right? The first equation, 100 minus x. And then it's going to say, what's your second curve? And then it's going to say, move to about the spot you want. See, there's 2 of them, right? Okay, so what I do is this when I'm using intersect. I move it down to the point where I want to find the intersection. Slowly and painfully, I move it down to the point. Okay, close enough. Okay, it's still saying, what's the first curve? So I hit enter. Then it says, what's the second curve? And now it's changed to the 1900 curve, right? So I hit enter. Then it says, give me a guess. So the reason I moved there is I can just hit enter 3 times, right? Because I'm on where the first curve and the second curve meet, and the guess is that this is about the spot, right? So just hit enter again, and we get 25.5. Okay, so about 25.5. But there's another value, right? So second calc intersect. Now, it's very painful for me to move this thing up here, so I don't want to move along here, right? Because it's shorter if I just move on a straight line. So I'm just going to say, I want my first curve to actually be the straight line, and then I'm just going to say, okay, move to the right along the straight line. And I move to the point, I'm not going to do this for the second one, you guys can give me the numbers. And I move to the point of intersection, and then I just hit enter 3 times, right? Because first curve, second curve, that's where they meet, and the guess, I am where I want to be. 1, 2, 3, and we get 74.5 to the nearest tenth. Whoops. Or Okay, so what are we going to do for the second one? Well, we're going to go back to y equals, and we're going to change 1900 to 2200. We're going to hit graph, and we're going to do the same thing, and you're going to give me the numbers because you're going to do it a lot faster than I could do it. Yeah, we time this right, or it's going to be right or wrong. Okay, what are the numbers? What's one number? What's the first number? 32.7. And the second number? God, I could do this. What's the second number? Oh, really? It's a surprise. Or 67.3. Okay, I didn't draw very good sticks, but I did write it before she said it. You saw it here. And one word for you, symmetry. Anyway, don't worry, we'll go into all that. You can also use the table function on your calculator to determine the areas for various widths and the widths for various areas. To do this, press that. Okay, before we do that, let's just go look in the table. So here's the table. Second function graph takes you to the table. Second table. Nice table, right? Lines in color. Here's this. Okay, so this tells you, okay, here's your y2s, right? That's just the straight line we drew. It's always 2200, so ignore that. So this tells you, hey, when that's 0, and that's 10, that's 900. Remember our table. We can scroll up, which doesn't really make any sense in the context of this question. We can't have negative width. But it is a parabola. It keeps going. Okay, nothing's stopping it, right? There are negative areas, but they don't make any sense, so we ignore them, right? That's why we've restricted the domain from 0 to 100 and the range from 0 to 2500, right? That's all we're interested in, okay? If we're doing a generic quadratic, which we will do many of, then we're interested in the whole thing, right? Now, let's say I wanted to duplicate the table we did. So if we go second table set, so table start, I'm going to say start at 0. Delta table, that says what change do you want to make? And I can say I want to go by tens. Okay, and then hit enter. And then I'm going to go back into the table. Now look, that's the table we did, right? So if you were lazy and knew how to do this a little while ago, or not lazy, if you knew how to do this a little while ago and you were smart, this is what you do. Right? So you could say, hey, give me a table that goes from 0 to 100 by tens, and yeah, there it is, right? You look back at your table and say, hey, it's the same table. You can also, okay, what do they say? Table start, delta table, type 5, values go up by 5. Ah, that's no big deal, right? We don't need to do that. We went up by 10. Use table, however, if we're going to do 25 centimeters, then we do need to go by 5s. Okay, so again, go to table set, change delta table to 5, and enter. All right, so I want 25, it's 1875. Right. I want to know when the area when the width is 2100. Look at the area is 2100, and I want to know the width, and the area is 30. Okay, so this is 1875 square centimeters, and this was 30 centimeters. Is that it? Like on time? It's amazing. In under 40 minutes. Okay, any questions?